following on from the previous video, when given a function, when given a function like this, remember you're not going to be given a graph like this. You're just going to be given this, and then from this we have to sketch our graph. Okay, but let's for the time being we're just learning. So let's give you this graph here. So when given a function like this, we can differentiate it to give us this, and then by looking at the derivative, we can then deduce some. We can then come up with some sort of information about the original function. So in the previous video, when you differentiate it, keep an eye out on f prime of x being 0. Okay, then that gives us some interesting points that we need to investigate. Okay, and now looking at this here, so in the previous video we've stated this here, and it's called a critical point. Okay, now look at this here. Keep an eye out on f prime of x being greater than 0. So when f prime of x is greater than 0, then you can say that the original function is always on the increase. It's always climbing. It's always increasing. So looking at this here, so keep an eye on f prime being greater than 0. Let's just look at our graph here. So looking at the blue line here represents our f prime here. So the blue line being greater than 0, that's this bit here, being greater than 0. That's from here to here. Okay, beyond here it would be in the negative realm. We're not interested in that. So when going back to here, hang on. Going back to this statement here, when f prime is greater than 0, f of x, the normal function, will always be increasing. So let's go back to this here. So when f prime, when the derivative is positive, then you can see that it is always climbing, because if you think about it, the gradient when the derivative when this thing here is positive, it means that the gradient is always positive. It's always up here. So the point here is that the gradient of the original line will always be positive, meaning that it must always be climbing. So the fact that this thing here is positive, it can only mean that the original function would always be climbing, because the gradient is always positive. The gradient is always positive, so it can only go up. Okay, so when the blue line here is negative, the original function, the gradient of the original function, is always going downhill, because it's a negative gradient. So it can only mean that it will go downhill, because the derivative here is negative. So when the derivative is negative, it can only mean that the original function, the gradient, is always pointing down. It's always going down. So it can only mean that the original function can only go down. Okay, and then looking at this here is positive here. That means the original function, the gradient, is always uphill. It's always meaning that it can only go up. It's the gradient. Well, it can only go up. Okay, so remember, when it's dead on 0 is a critical point. So this here is a critical point. This here is in this case is a turning point. But then when this thing here is negative, then you can, when it's negative, then you can see that the original function is always going downhill. Okay, so hang on. So in the previous video we've established this. In this video, when f prime is greater than 0, the original function can only be climbing. Okay, and when f prime is less than 0, the original function can only be going downhill. It can only be going downhill. Okay.